Nature creates the conditions that support life. Nice. Should we do less? Nice. Oh, that's very nice. Where'd you get that?
I made it.
Right. Custom made. Yeah.
Yeah, I did a whole bunch of them at one time and it never went anywhere. So where I made these, I don't think exists, but I don't think this account exists anymore. It's been so long. And I just haven't gone back to do more. I've got the shirts that we did are up on the network, but I haven't gone back to do all this. It's just time.
Yeah. Well, your energy and coloring and everything look like good, healthy.
Yeah. No, I'm getting back to normal. Still have this thing in my arm. So 2 more weeks and that'll be gone.
What's the thing in your arm?
It's a pick line.
What's that?
It's uh, a hole in your arm that has a needle in it so that they can give you stuff on a regular basis.
Okay.
So
Oh,
they can take blood and give you things, both.
all right.
So yeah, so every day at 1 o'clock I go down and get drugs.
Uh-huh. And what's that to address? What is the
It's to prevent infection from the
big?
last operation.
Okay, all right. Yeah.
Yeah, I had 2 hip operations in 5 weeks.
Right. Whew.
And the last one was a clean out of the first, basically. And so they put me on antibiotics at that time so that it wouldn't get infected or there wouldn't be an infection.
Yeah.
Yeah. So 6 weeks of antibiotics, 2 more
Oh,
left.
all right. So, where are we in relation to everything today? Yeah.
Yeah. Yeah, it's interesting. I'm going to talk climate change for a minute because that's just what came up.
Okay.
There are so many stories that we got attached to about what is happening and how we can do stuff about it as we've kind of felt our way into the process. And carbon was the first thing that we latched onto. It was actually only half the story, but it was the half easiest to understand for people. And so we were really caught in carbon, and carbon's, we've got to sequester carbon, we've got to put it in the ground. That's really important. And it is important, but it's not changing much. What is more important is to stop putting it in the air, which none of us have any control over and which we haven't been very effective at. And while I think the world in general has reduced its energy requirements, with crypto and AI, they are huge uses of energy. So our energy use has actually increased. And I'm blaming it on those two things because they're really strong right now and they use a lot of energy. So the whole thing about not doing carbon is just like this, we're not paying attention to that. And it's not having any lady. Thank you, ma'am. Um, it's not having much of an effect. And even if it did, well, if we stop putting carbon in the air, that would have a big effect. But the sequester process is slow and it doesn't have a big effect for a long time. But we're really caught in that. And that's so much. Even Al Gore, I just went through Al Gore's training and got certified, and he's saying that the climate crisis is a carbon crisis, and it's not. And the other thing that's come up is
Well, what
cows.
is it? If it's not carbon, what is it?
We'll
What's it?
talk about that in a minute.
Okay. Okay.
So the other thing is cows. So people are really, cows belch methane. Well, they do belch methane when they eat grain, but they're not designed to eat grain. They're grass eaters. And they don't do that when they eat grass. So we're blaming the cows, and it's not the cows, it's how we're managing the cows. So there's this whole thing about not eating meat. Well, that's not a bad thing either, because we're destroying forests to create grazing land, and that's not a good thing. That's a really really, 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 really bad thing. So, but cows are really not the problem. They can be part of the solution, because we need grass, and cows are together. And so the grass needs to be chewed by cows. And those cattle ranchers, which have moved from raising cattle to raising grass, paying attention to how they're growing the grass that the cows feed on, are actually able to expand the number of cows they put on that grass, because the grass is actually able to manage that if it's managed right. But we're not paying attention to the grass. It's there. The cows eat it. And grass, like every other plant, needs to be nourished. The soil in the grass that the grass is in needs to be nourished. If you nourish the soil and grow that grass, then the cows are not a problem. So we've got all these things that we think we're doing, and they're really not, because we don't understand the cycles that we've interrupted, which we're just starting to learn. So you ask what's the issue? The issue is water management, because water in a healthy planet is part of a cycle. And it rains, it goes into the soil, it goes into plants, the plants transfer evaporation and bacteria, and it rains again. And that's the cycle that keeps things healthy. But it has to have soil that will hold the water, because if the soil doesn't hold the water, even if the rain comes down, it washes away, and that's when we get floods. So the soil holding water is like the biggest key to shifting climate change, because the problems that we're having with the flooding and the drought have to do with water in the air that can't come down because there's no green. It won't come down if there's no green. If it's hot and dry, it goes right over.
Is that right?
It will only rain where there's green. Yes.
What's the dynamic of that?
Well, that heat pushes the water up. The heat that's coming off the hot, dry land is an updraft, basically. And so rain just goes right over it. And the dynamics of water changing from liquid to gas and then back to liquid actually is a process where it gives off or uses heat. So that is a temperature mechanism. That process of changing water from one form to another requires heat. So it takes heat from the atmosphere and cools it. And when it doesn't rain, it doesn't do that. It stays hotter, because the rain is the cooling thing. It takes that heat away, uses that heat to try to change form.
So you're laying out steps of a cycle that that we affect. I
Yeah.
don't have the picture yet. I don't
So
have the cycle yet.
well, because you have to have plants to pull the water out of the soil. If you don't have plants, if there's no plants there, the soil is hot, and it's usually hard, and it's usually dead. Because what keeps water in the soil is the life in the soil. And if the soil doesn't have life, it can't hold water. So when we take plants away, when we pave things, when we just destroy the plant life and leave the soil bare, when we poison the soil with all our chemicals and stuff, and so there's really no life in the soil, at those times, the soil doesn't hold water. And that's part of the problem with farming now. And especially if the farms are on sandy soil, they can grow stuff if they put chemicals on it, but that's not affecting the soil at all. And the sand does not have a lot of life. It's mostly silica. And so it doesn't hold water. It goes right through. And it needs to stay there. And you can change that by adding life to the soil. And you can do it fairly fast. I was just listening to a video. He did it in about a year. He made a huge difference. It's not done, but he's really made a huge shift in terms of the amount of water that his soil will hold, even though it's still sand, because he's put life in it.
What is this cyclic process that you're describing called? What's
It's
the
the biotic pump.
right? Okay, which I still don't have a good understanding of.
Well, it's not hard. I mean, it's composed of healthy soil, a land designed to hold water long enough for the water to sink into it, plants that will pull that water out, and then rain that will come because those plants are evapotranspiring.
And what is our part in that?
Our part is to make sure that the soil is healthy and alive and that there are plants on it. Those are the two things that we can do. We can design land to hold water, we can support health in the soil, and we can plant plants. Those are all three things we can do. And everywhere we do it, we're helping to make that cycle alive.
So say again the steps to cultivating a living soil.
Are putting life back into the soil, and we can do that with biologics. We can do that with compost and biologics and biochar. Those three things help soil become alive. And then we design the land. We work with nature's land contours to make sure that water, when it comes down, has a place to stay, not run off. So creating swales and dry creeks and rain gardens, all of those things help water to slow down long enough to sink, because it takes time to go down in the soil. So you have to give water time. We tend to siphon it off, to direct it away from things. And that means that the water goes away. We don't have it. And you want to keep it, but the only place to keep it is in the dirt, not in tubs and barrels and that kind of stuff. That's not horrible. It means you have access to water, but it means the soil doesn't have access. And the soil is what needs it. It's the life in the soil that needs that water. And the soil food web is really fantastic. They're a school that teaches people about soil and composting and stuff. And they actually have processes where you can see with a microscope the life in your soil. And
That.
it is. It's fun and exciting for people. They just love it because you can see the different kind of critters, and you can see how that you can measure them. You can see how many they have. And so you know when your soil is getting more healthy or not.
Is there a video on YouTube?
Oh, there's tons of them. Yes, just tons. Just
Well,
Google the soil food web, and she's got thousands of videos. She's wonderful. Elaine Ingram, she's been doing it since 2019, I think.
soil food web.
Yep, school.
What's
School.
school? Soil food web school.
Yeah, it's what it is. It's a school.
Huh. Um, what is its stage of development at this point?
Oh, they've been in existence since 2019. So they work all over the world. They've got stories from farmers all over the world. They're now training people as a career to be a consultant to farmers and other people who have plants and stuff to help them with their soil and composting. Um, and they're training farmers who just want to learn how to do it on their own land. So they've got just tons of classes and educational stuff and um, stories of where it's worked all over the world. Yeah.
What I assume you're part of a local group that is involved in this. What
Not, not really. That was sort of something that I realized yesterday that we have a composting group here, but they may not be doing the kind of composting they think they're doing because they're not really looking. They don't use microscopes. They don't see what's in the soil. So they're just guessing. And it can look really good and still not have the life in it for lots of reasons. Because it needs fungi and it needs bacteria and it needs protozoa and it needs nematodes and stuff. And sometimes it just doesn't have that for all the things that we do to soil.
are those things it needs again?
So it's bacteria, protozoa. The protozoa eat bacteria. Nematodes eat protozoa.
What's
And
neos?
nematodes are things like worms and their little squiggly stuff. They're sort of a classification of animal that come in different sizes.
Nematose? How do you spell it?
And I'm not sure. Netamotdes, I guess. Des.
Say it again.
Nematodes. Yeah.
Nematos?
Yeah, don't trust me on that. It's Neem, N-E-M
Oh, that's
A-T-O-D-E-S.
Godes.
D is in dog. Uh-huh.
Oh, nematodes.
Yeah.
And they are what?
And fungi. They're a classification of critter.
They're
Microscopic, yeah.
microscopic. Okay. I know I have a thing for fungi. I love fungi.
Yeah.
I marvel
Oh,
at
they are. They're just amazing. I mean, they're
oh
all so different and they glow in the dark and they just do very, you know, I've been reading a book called Light Eaters.
light eaters.
Yes, I really recommend it. You will love it. And it's all
Okay.
about plants. It's all about the discoveries that botanists have been making about how plants work. And they are calculating, strategizing, clever, inventive, intentional beings. They do amazing things. They have language, they talk to each other,
and
they plan.
and that's what you call nematodes.
Well, nematodes are critters in the soil. So they're not plants. They're more insect-like.
And the thing they're just then the light eaters are called what?
Light eaters are plants. That's what plants do is they eat light, right?
I don't know. I guess I you
Well,
say
that's what photosynthesis is.
right. I've always been awed by the word photosynthesis because I know that it's central to life.
Yeah, it is. It's without it, we wouldn't be here.
Yeah, I've I'm awed by
Yeah.
photos.
Oh, yeah. 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 And it's oh gosh, she Zoe is the author. and I'm not going to say her last name right. It starts with an S, but she writes really well. And one of the stories she tells, sort of in passing actually, is um, the time that a cell's glommed onto a cell that does photosynthesis and said, I want you. You're part of me now. And that allowed plants to happen. That's how plants came into being. And there is a, a green slug, which actually starts out brown with red spots as a baby. And then it finds an algae. And when it finds this algae, it takes the chlorophyll out of the algae and keeps it. So it eats the chlorophyll, eats the algae, and it digests part of the cell, but it keeps the chlorophyll, the part that does the photosynthesis. And so eventually it turns green and it no longer eats. It can now live through photosynthesis. This is an animal.
Would you say that again? Lord.
Yeah. So it's a worm. It's a worm. Yeah. And it's brown with red spots when it's born. And then it finds an algae. And when it finds the algae, it eats the algae and it keeps the chlorophyll, the parts of the algae that photosynthesize. And in so doing, it becomes green itself. It's bright green. And then it stops eating because it can get its food through photosynthesis. It doesn't need to eat.
Photosynthesis is such a it's central, it's big, it's like
Yeah.
everything.
Yeah.
It's
Yeah.
it's life's process.
It's the foundation of all life on the planet.
It's foundation of, yeah.
Yeah.
Just a simple word, photosynthesis. And how would you sum up that process? What the description you would
Well,
give to that process?
it's the changing of light into sugar because that's what plants do. And then the sugars become food. They feed everything else through sugars. And that's what the fungi and stuff get from plants is the sugars because they can't photosynthesize.
Right. Fungi doesn't photosynthesize.
Right. So they have to use other plants to live, which they do. They live on other plants.
Do you have access to a good video about this?
I haven't seen anything actually that really focuses on photosynthesis as such. No, I'm sure it's out there. I would Google YouTube and see what you find.
Uh-huh. It's just so magical. I mean,
Yeah, it is.
magical.
Yeah. Yep. Yep. Yeah, and that's one of the things I like about compost because it's magical too. I mean, you're taking garbage and you put it all together and let it sit for a little bit, and then you have this magic of life, of all these critters, and it's brown and clean and good smelling and all of that. Um, yeah, it's just you really have to pay so much attention. I had no idea how I want to say complex, and I guess it is in a way, compost is, but because it's a living thing, it needs to be treated with the same respect that other living things are treated. And so you have to pay attention to how you make it so that those living things can be there. So what you put together and the need for water because it gets hot and it burns off that water. So you have to put more water on to keep it going so that life can eat. That's what that heat is. I mean, I don't think we really appreciate um, how the planet's temperature is regulated. We think there's a button that you push, and it's not like that. All of these natural processes that give off heat or require heat, it's that fluctuation that keeps the temperature where it is. I mean, that was Lovelock's insight, is that it's stayed the same for 65 million years. How is that possible? And it's possible because these processes are happening all the time. And so that just manages the regularity. We've gotten in and stopped some of those processes, because as we take plants off land, as we pave it or kill them or whatever it is we do, we're interrupting that cycle. We're stopping parts of the planet from doing what it normally do. And it needs all of that to keep that regulation. I mean, it needed all that work. So we've kind of cut off the amount of the planet that's doing that regulation. And it's getting hotter. That's what happens. You know, at least for a while, that's what will happen. So,
It's getting hotter because what?
because there's not enough land planted to keep the rain coming down. So the rain goes up and it stays up there until there's so much of it, it has to come down, and then we get floods. We get these torrential rains and hurricanes and all that kind of stuff, because the gentle cycles are being interrupted by our actions.
So the bionic pump is 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 a process, is a relational process of soil, sun,
Plants.
plants.
Yeah, soil and plants and sun and water.
Um, and what what are the people what are the people called that manage that work on that? What is that system? I mean,
Watch
what
why
is that
Japanese
process
people eat white rice.
called? What was that?
I'm looking for something here.
Oh, yeah. What is
Um,
that process? Because photosynthesis is natural.
well, I mean, it's the water cycle, but the water cycle as we know it has not really included dirt or soil. It's only included plants and air. And that's been a problem.
You said, as we know it. What does it have to do with what we know and what we don't know? I mean, it's its own
Oh,
cycle.
it exists, but if we don't know about it, we can't help it. And we get in the way of it because we don't understand what we're doing.
Yeah.
And now that we see there's a problem, okay. So you want a 7-minute video?
Exactly how trees can both.
Let's see. This is a great video. It's kind of fun.
Trees make water. It's the truth. And in this video, I'm going to explain exactly how trees can both create water when they're planted and destroy water when they're removed. So let's start with the simple structure of a tree as a giant net for capturing atmospheric moisture and nutrients. The combined surface area of a tree's leaves or needles, branches, and trunks is surprisingly large when you imagine humid air, fog moving through the tree and intercepting each of its surfaces. Atmospheric humidity condenses on every surface of the tree as moist air rolls through. The water is settled out of the atmosphere and collected by the tree. And it's not only moisture that's caught by the tree's net, it's also fine particles of dust, pollen, spores, insect bodies, bird droppings, and more that are all collected by the vast net of the tree's structure. So when moisture is collected by the tree, sometimes in the form of frost when it's cold, it drips off the leaves, bringing all of these atmospheric nutrients with it to the soil level and down into the tree's root zones. This humidity harvested by trees can actually account for a large proportion of the total precipitation that falls on a forest. And then, when the rain comes, the whole surface of the tree is a giant intercept for falling rain. Each raindrop's fall is broken when it hits the tree and splatters into a fine mist, where the structure of the tree itself directs the flowing water through it, down the branches and trunk, dripping through the interwoven network of leaves, washing all the dust and pollen and bird poop gently down into the tree's root zone. The soil below the tree is already spongy from all of the leaf litter and sheltered environment beneath the tree. So the water soaks through the soil sponge and is drunk up by the tree's roots. The tree becomes full of water. Just like the human body on average is 60% water, the body of a tree on average is 50% water, both above and below ground in the root system. So imagine a forest on top of a hill. So with 50% of every tree made up of water, you can think of a forest on a hill as like a lake's worth of water just sitting there. Remember, the total canopy of a forest is intercepting fog, humidity, and nutrient-laden dust. So it's collecting water and nutrients even when it's not raining. Then when it rains, the whole canopy breaks the speed of the raindrops and gently drips the rain where the tree's structure directs it to. And then the spongy soil soaks it up and the roots drink it in. And what's not absorbed flows downhill into the creeks and rivers below. So the hilltop forest moderates the time it takes for water to move through the hill. It slows the duration that it takes the water to move down through the landscape and keeps a big storage of water at the top of the hill in the form of the forest, which will slowly release water over the seasons as gravity pulls it down. But at the same time that gravity is pulling the water down, the tree is also pulling the water up and out of the leaves and back up into the atmosphere through evapotranspiration and evaporation. And it's not just water that's rising up and out of the trees. A forest releases many tiny particles like pollen, leaf dust, bacteria, fungus spores that float up into the air. When these tiny particles encounter moisture floating through the atmosphere like clouds, then the forest particles provide nuclei for raindrops to form around. So we have clouds that have formed from evaporated water over oceans and seas, moving through the atmosphere over land. And then they encounter the air above a forest, which is filled with water vapor and organic particles. And guess what happens when they all meet? It rains. Studies in the Amazon show that the forest there actually returns 75% of its water back into the atmosphere in amounts high enough to form their own rain clouds. But it's not just the wet tropics we're talking about. Trees in every climate have a partnership with the atmosphere. Trees collaborate with the atmosphere to produce rain and snowfall. And so the clouds that you see move overhead are not just ocean water vapor, they're forest water as well. In fact, forested mountain ranges help to leapfrog water from the coasts to the interior of the continents as water vapor hops from one mountain range to the next. The rainfall in the interior of a continent is dependent on the forests on the coast. So when you remove trees from this cycle through deforestation, you break the system. It rains less on barren land because forests aren't there to intercept the clouds with water vapor and raindrop nuclei. And when you break the system on the coasts, it then has sad repercussions for rainfall further inland. It's called drought. Remember, trees don't only bring water vapor and raindrop nuclei into the atmosphere, they also moderate the flow of water down into the landscape, making it more consistent and steady because the forest is a giant sponge of water storage. So when you remove that sponge and then the rain falls, the water rushes down off bare hillsides quickly below and all at once. And down below the barren hills, you get floods in the valleys. So, my friends, this sorry state of affairs is what we call the drought flood cycle. And this is where much of the world is today. Long droughts punctuated by short, intense floods. And shortly after the floods are over, the droughts start again. But as I've shown, in many cases, the course to take is obvious. Trees make water. Trees moderate the flow of water. Forests are part of the circulation of atmospheric moisture. It's really pretty basic, and hence the solutions are basic as well. Honestly, we can undo this mess. We can just get our heads and hearts straight. So go plant some trees.
And actually, it's not just trees. That's another little thing we've gotten hooked in. It's not just trees, it's forest. Because monocultures do not do that well. And I'm going to put in the chat the name of the main bacteria, which is called Pseudomonas syringae. And that's the bacteria, the main bacteria that the trees release that act as seeds for water molecules to become raindrops.
You haven't put it in the chat yet.
Oh, yes, I put it in the chat, but I forgot to send it. There you go.
Pseudomonas, say it,
Pseudomonas syringae.
Pseudomonas syringae. And that is what?
That's the bacteria the trees give off. It's the main one. There's a bunch of them, but this is the one that seems to be the most prominent worldwide.
And you're saying Pseudomonas syringae is a bacteria?
Yeah, that the trees give off, which act as nuclei for water droplets to form rain.
Oh my God. That's awesome.
Yeah.
Oh. Pseudomonas, say it again.
Pseudomonas syringae.
Is
the bacteria.
Is what?
The bacteria.
Okay, the bacteria that
forms the nucleus for water droplets to become rain droplets. So the water vapor in the air coalesces around these bacteria and becomes water at that point so that it can actually fall as rain.
Would you repeat that, please? Starting with pronouncing Pseudomonas syringae.
Syringae, yeah.
Syringae.
Pseudomonas syringae is a bacteria that allows the water vapor to go from vapor to water, to coalesce around it to become water so that it can drop as rain.
Say that one more time, please.
So the water vapor will coalesce around the bacteria and transform from vapor to water.
Water vapor coalesces around bacteria.
Yeah. and that makes a water droplet, which then becomes rain. So that bacteria is a key in the shift of water's form from vapor to liquid.
Is there a book on this? That you know?
I don't know there's books yet. There's lots of papers, but there's not, I haven't seen books so much. Yeah, and LinkedIn, there's a lady, Fleming is her last name. It's not Nicolette, because Nicolette is somebody else. Anyway, she is really wonderful. She's been learning all this like I have, and she's just got a way of talking about it that is fabulous. And some of her posts are just hilarious. I've talked with her. She's a Mormon, actually. And she wants to be a programmer. But she's just doing amazing things with this. One of her posts is like, so we're having a water problem. Really? We're on a water planet. Why are we having a water problem? And then she goes off into all of this to talk about how the cycle works just fine, folks, if we don't get in the way of it. There's tons of water on the planet. We aren't having a water shortage. We have a water cycle interrupt. That's what we have. It's not about a shortage of water. There is no shortage of water. We are simply not allowing it to do the process that makes it available to us. We have interfered with that. And she's just got this attitude. It's just wonderful. She's just hilarious.
And her name?
Yeah, her name, I don't know. Let's see, where can I find it fast?
Because Pseudomonas cingare is something else. That's a process, right?
That's a bacteria.
That's a bacteria.
Right.
And water coalesces around bacteria.
Right. And other things, but that bacteria is the prime mover.
But I'll look up this woman's name, though, you know what
Yeah,
you
just a minute, I can find it for you. She's fabulous. She's just fabulous. Um,
has this information found its way into elementary school education?
no.
I mean,
Natalie Fleming is her name.
Natalie Fleming?
Yep.
Hmm.
Yeah, let's see if I can find her.
Natalie Fleming.
So here is a YouTube that she has shared. I can put that in the chat. And this is another woman. Well, this isn't. This is a guy, Gerald Pollock. Oh, well, you might find this interesting, though. Let's see. So this is a YouTube that you can look at it. It's about cells and that kind of stuff.
Let's see.
And Natalie.
Let's see. Okay.
So this is Natalie's LinkedIn information. She's just hilarious. She's just really wonderful. I would love to have her involved with Soil Smart, but she really wants to seem to stay separate, but we'll see. We'll keep talking and maybe I can persuade her to do something. If I had money, it would really help.
Well, how would money help?
Oh, well, I mean,
to
I'm
engage her.
at the point where I really would like to hire some people to do stuff so that we can really work together. And she's one of them. And I'm really looking for, I'm going to try and find people who have been recently trained at the Soil Food Web, because somebody who really understands composting. Because it's just, that's not my best use of time and energy. I know about it, but I don't want to be a compost teacher. But we need somebody here who understands compost and ideally who has farming background so that they can really talk to the farmers around here, which I can't do. So I'd like to hire somebody like that. And I'd like to hire somebody who's been trained with Zach Weiss to design land to hold water, so that we could actually help people do that. There's one guy here, but he's up to his ears. That's the trouble when they start doing it as a business, they get so swamped. Um, there's just more work than they can manage, and they don't do anything else. It's really hard. Zach only is talking to people because he's built his business to the point where he's got lots of other folks doing the work. Um, and he's been doing it worldwide for decades. Uh, so I would like to hire those three people, actually four people. I would like to hire a grant writer. That would be the other person I would hire. And then I think we would be we'd be able to do stuff. We'd have the money and the method that feeds the machine, basically, money to do that.
There, there we are again. Um, I'm trying to figure out how to how to save, how to copy some of what you put in the,
So
and
so you can copy the chat. If you look, if you put your cursor on the link, you'll see to the right there's three little dots.
yeah,
So click on those three little dots and it says copy.
it says save chat.
Well, you can do that too, and that will save everything. But each link, each entrance by anybody in a chat, to the right, there are three dots, and you can copy just that if you want to. And at the bottom where there's three dots, or at the top where there's three dots, you can copy the whole chat all at once.
I only see the three dots at the top. I don't see anything at the bottom.
Well, you have to put your cursor on the link that I sent. And then on the right of that link, you'll see three dots also.
On the link that you sent.
Yeah. So I sent you a YouTube link and a LinkedIn link.
Oops. Where'd everybody go? Where did we go? I'm not seeing us. Let's see.
So remember we talked about there are layers on the computer. So you've gone to a different layer.
Coming home project. Zoom meeting, join with Zoom.
Yeah, if you find Zoom on your dock, that will bring you right back.
It's loading, but there we are. I mean, it's just so fascinating. I mean, it's information that our species needs to be indoctrinated with this information to be as part of nature.
Yep.
We are.
Yeah, I'm hoping to work with Fritjof Capra's started a educational group that's systems thinking and environment. And I don't know what their thinking is. I don't know how far along they are, but I've been trying to talk to somebody from that group, because I would like to work with them to do a curriculum for science teachers to begin to create science classes that have to do with a forest, which we will then plant outside the school. So they'd have a forest there to play with and to learn from and to pay attention to. Yeah, but we'll
Is-
see.
So there aren't a lot of barriers to that, social barriers to that. I mean, how?
Well, not so much social, I don't think. It's just finding the right people and the time it takes. So I have a conversation next week with the school district. So hopefully I'll get them on board and then they will help us find land to plant as a Miyawaki forest. So that's part of it. And then to find,
Miyawaki?
yeah, it's the Japanese guy who created the process for doing fast forest.
You know how to spell his name?
Uh-huh, I can put it in the chat.
Okay. Miyawaki.
Yeah,
Miyawaki. Miyawaki. And Miyawaki is what?
the Japanese man.
Who is doing what?
He created the process for planting fast forests, small fast forests. So you can plant a real forest in a day in probably the size of your bedroom or your house, maybe your apartment.
Mhm.
And in 3 years, it's self-sustaining, and in 25 years, it mimics old growth. And it brings back all the insects and critters and birds and all that kind of stuff that used to be there.
And what is the engine for this vital information? What organization, what?
Well, there's lots of organizations now, but Miyawaki was the guy who created it and taught it to people. And now it's being done worldwide by a variety of different organizations.
And what is this process called? What is
It's
this?
the Miyawaki Forest.
Milwaukee Forest after his name.
Yeah.
Okay.
You can Google that too. You'll find lots of stuff.
Yeah. Yeah, because do you have a sense of how deeply this information has come into childhood education?
No, not very much.
Uh,
Yeah. Yeah, there's occasional places where it's done. I know in Berkeley, there was a lady who's done a lot of Miyawaki forests in Berkeley on school ground, but I don't know if she's done anything about the education process.
Milwaukee Forest, right. Because it seems like the school system would be the perfect place.
Well, their school systems are very slow to change. They do not welcome new information with open arms, usually.
So what could get them to do that?
Well, I'm hoping that we can do that with the gift of a forest, that they will also accept a curriculum. We'll see. You know,
Well, I sure appreciate what you're doing and what you're trying to do.
yeah,
And
it's all baby steps.
what?
It's all baby steps.
Uh-huh. It is baby steps, but it's important. I mean, the first few steps of a baby is vital.
Really? Yeah. Without those, there are no more.
The perfect place to start.
Yeah. Yes. Yes.
And Natalie Fleming is who?
She's a Mormon woman who's been educated like I am by listening to other people who know more than we do. But she's got a great attitude and she's really sharing what she knows on LinkedIn in wonderful ways. So she's very entertaining and just really right on. She's just really great to read. She's a lot of fun.
And I can find her on YouTube, right?
I don't know. I gave you the LinkedIn to her.
Oh,
So yeah, that link is to her feed on LinkedIn. So you can read her post there.
okay. And I saved the chat.
Yeah,
Where,
just click on the link. It will take you right there if you do that now.
but then I lose you and
Yeah,
then
you do. But you can come back. You just go down to Zoom and you can come back.
I have to join LinkedIn and make up a password, and I don't want to do that right now.
Oh, okay. Well, then you won't have access to her stuff. That's okay.
But I've got her name, Natalie Fleming.
Yeah, you can Google her and see if you can find her other places.
Yeah, I want to come back to us. I want to see. There we are.
Good.
Good. Yeah. So, um, I know you're part of a city group, right? You're
Mhm.
and and this is a focus of the group that you're part of.
Well, I'm trying to get them to see it as a focus. They
Yeah.
don't.
Is there any way I can help?
I don't know. I mean, that's just talking to people and changing minds over time. So
Right. Keep at it, girlfriend.
yeah, it's all you can do. Yeah. So I'm talking to the president of the city council next week also, and I'm trying. She's also been part of a group called the Carl Maxey Center, which is a Black community center that's been started a couple of years ago here, and is still struggling a bit, but she's been on the board. And so I'm going to suggest a Miyawaki Forest for them and see if she has any interest in helping that to happen. And then we can do the same thing, you know. There needs to be some sort of understanding of why it's there and what it does and all that kind of stuff. And then it can become part of the center and an attractor for people coming to the center, and it keeps the center cool, and you know they can actually see all that happening if they want to. So we'll see.
So, what groups are you part of in your locale?
Well, I was just appointed to the Spokane Climate Resilience and Sustainability Board. So I'm doing that, and I'm going to be appointed to one of the park districts advisory committees, and I'm not sure which one. I don't remember how that's happening. So I will have a voice on to the park board also, and trying to get them to understand this and then to work with it.
Do you have the audio visual things that you need?
Yes, yeah, I mean, it's on Zoom or in person, so that's not a hard thing. So I'm in the process of interviewing the city council so that I can see what they would like to have happen on these boards and then talk to them about what I would like to see happen on these boards. And I've had one conversation so far and it was excellent. He didn't know any of this. He was really impressed and surprised and suggested I talk to other people. So, you know, that's
Good,
how it goes. So
good.
Yeah. So it's just a long, slow process.
Milwaukee Forest.
Yeah,
And
it's been done all worldwide in all sorts of environments. It's just understanding the process and doing it. And you know what's funny is for some reason, people just don't pay any attention to soil. You know, it's under our feet. We just don't pay any attention to it. So they plant trees without paying any attention to soil. And not only that, when you tell them, well, you know, maybe if you improve the soil before you put the tree down, it would help. They go, really? I don't know. That's controversial, don't you think? No, I don't. But they just don't. You know, I'm wheedling my way in. We've got $6 million to spend on planting trees in the next 3 years. And if they just added soil prep before they planted the trees, it would make a huge difference. And they just are not willing to do it yet.
so, and what would the soil prep consist of?
Well, it would consist of, in my mind, really good compost. And again, that's a whole discussion, which we haven't had, and biochar. And that would be my recommendation. And the biochar has to be inoculated, so it's actually feeding the trees right away. And that would help hold water. It would do all sorts of things. And they do throw in a handful of biochar in some of the trees, but I don't know if it's inoculated. And if it's not inoculated, it's actually going to take things away from the tree for a year.
Inoculated with what?
Compost tea is really a good thing. Or have it spend a few months with compost, and then it will absorb, it will inoculate itself. But it's biochar is like this big carbon apartment system. So it's full of holes. It's very porous. And all those holes are empty. But if you put stuff in the holes, then it has food to share. If it doesn't have anything in the holes, then it grabs stuff to put in the holes because that's what it wants to do.
Well,
And so
what
it will detoxify soil. It will take, they're saying it will take forever chemicals out of water. I haven't found a paper that proves that yet, but that's what I've heard that they have done. And if that's true, that is huge because those forever chemicals are in our water, are in our soil, and there's nothing to get them out right now. There are some bacteria that I think are eating some of them, but that's a real slow process. And if the biochar could take it out of contact and store it, which it does, it holds things, then that could be a very helpful step. So I just did a really wonderful webinar on biochar, and with a computer glitch, it did not get saved. So
oh,
yeah, really, you have no idea. It was just amazing. And it's, yes.
and nobody who was on board with you saved it either?
No, everybody was presenting and talking and doing stuff. That was my job.
Oh,
So yes. So we'll redo it. Just will take a few months to get all that together again.
well, keep on, girlfriend. You're doing a
Yeah.
great job.
It's the second time I've done that, so I'm going to do it a third time. And we have had problems with it both times. So
you're just shining your expertise up.
stubbornness, more likely. Yeah.
Well, that's essential.
Appropriately used.
Yeah. Boy, well, thank you for doing what you're doing.
Yep. And it's time to go.
You're being acknowledged. You're you know, I mean, city council and advisory
Yeah,
committee.
the city council is, yes. Yeah, actually, that was kind of nice. I went down they asked me to come down and tell them why I should be on the board. And so I did. And the representative from my district was very supportive. He was really sweet. And he said, I voted for you. And it's no, I don't vote for everybody.
Oh, yeah,
So that was good. Yeah. He's a Republican.
ah, and he voted for you.
He did.
There's hope for the world yet.
Yes. No, he's a pretty good guy, actually. Yeah. In a lot of ways. It's just unfortunate that he's also a Republican. That kind of cramps his style, I think.
So, how is your daughter, and where are you in relation to your living space? Because you were thinking about moving.
Yeah, no, that's still all up in the air. Yeah, we've had a couple of glitches and all of that, so I don't know how that's going to work out. We'll see.
Okay. All right. What else? Anything else?
No, but we are at our time.
Okay.
So yeah, I have to get on with my life and get down to the hospital.
Uh, for treatment?
Yep. Yeah.
So how long will you be receiving treatments?
Till the 17th of
Oh.
November.
Okay. Well, good. All right. Well, keep me posted.
All right. All right. We'll see you next week.
I'll be with you. Okay, hun. Bye.
Okay. Bye-bye.